Before we work on this equation, check out this situation over here. We have 3 raised to the 4th power, and then that equals 3 raised to the x power. What would have to be the value of x here? Of course, that would be 4, okay, because we have the same base. So if the bases are the same, the exponents have to be the same as well. So let's take that philosophy and apply it to this situation. We have a base of 3 here, and we have a base of 81 here with an invisible exponent of 1. Okay, let's try to make this 81 to the 1st power a number that has a base of 3. So I'm going to rewrite this part right here, 3 to the 2x plus 1 power, and then I'm going to change this to a 3. So can we take 3 and raise it to a power that would give us 81? And we can. That would be 3 to the 4th power. So now, because I have the base of 3 here and here, then I can set the exponents equal to each other. So that will be 2x plus 1, which equals 4, and then we can solve this. And we will be left with x that equals 3/2. Okay, that will be our final answer. If you didn't want to solve it that way, you could have taken this original equation right here and moved it into log form. We would have had to done log base of 3, or log base 3 of 81 equals 2x plus 1. And you could have solved it that way as well. You would have evaluated log 3 of 81, and then that would equal 2x plus 1 and solve it and all that stuff. So that would have been a second option. Okay, now with this problem we have a 4 as a base and 8 as a base. They're different obviously, so we can't set the exponents equal to each other. So let's try to come up with bases that are both prime numbers. We could change 4 right here. We could do 2 to the 2nd power, right? 2 squared is going to be 4. That will equal this. Well, remember we also have in the exponent a 2x. So we'll rewrite this part so it equals this, alright? And then we have an 8. Well, we can make that a base of 2. 2 to the what power gives us 8, and that's going to be 3. And then again, remember we have x minus 1 up there. So now, because we have bases that are both the same, we could almost like cancel those out, and we could just set the exponents equal to each other. So we have 2 times 2x will be, whoops, I shouldn't put that. Let's do 4x, and then 3 times x will be 3x. 3 times negative 1 will be a negative 3, and then just solve that. So if I subtract out this 3x from both sides, I'm left with an x equals 3, well, negative 3, and that would be our final answer right there. You could have also taken our original equation and switched it to log form. So that would have been log base 4 of 8 to the x minus 1 power, which would equal 2x. That would be log form of this part right here. Now, you would have had to apply the property of, or the power property, so this x minus 1 would have to go to the front. It would swing to the front of this. So you'd have x minus 1 in front, log 4 of 8, which equals 2x. Then the next step you would have done would be log 4 of 8. And if I evaluate that, it's going to be 1.5. So I would have x minus 1 times 1.5. That would equal 2x. And then I have to distribute this number with this binomial. So we'd have 1.5x minus 1.5 equals 2x. And then I'd solve this and I'd get an answer of x equals negative 3. If we want to go ahead and do that, we can subtract 1.5x from both sides. We'd be left with negative 1.5 equals 0.5x. And then I'll go ahead and show what I do here. Divide out the negative 0.5, I'm sorry, divide out the 0.5, and then divide out 0.5 from over here, and that will be x equaling a negative 3, which would give us our same answer that we got over here. But that's about it. If I go back to this original problem, remember we always want to try to either get the bases the same. If you can't quickly figure out how to do that, just go ahead and switch it to log form. That's okay as well. If I go back to the second problem, again, we had to switch both bases, contrary to the first problem where we only had to switch one base. And then we had to distribute whatever our exponent was that we had to move in. We had to multiply that by our original exponent and then go ahead and solve. But sometimes it's easier just to go ahead and switch it to log form, but it's up to you.